friends, this is continuation of our previous video. The last video we have find initial feasible solution of the given problem using northwest corner method, least cost method. Finally we done with the Vogel's method. From that one the Vogel's method gives the better result. So all are initial feasible solution, it's not the optimal solution. Now we are going to the same problem, we are going to solve, find the optimal solution. So to find the optimal solution, we are going to use modified distribution method, that is we called as MODI method. Further some people they called as a UV method also. So first of all I will take as a initial basic feasible solution from northwest corner method. So this is the alignment. So this is the what is the red color is right in me, this is called allocation, this green color is here cost, this is the supply, this is the demand. So we got it, the cost is initial feasible solution cost is 180. We got it from our previous video. Now I am going to apply to the modified distribution method. First of all I want to introduce the dual variables u1 u1 u2 u3. Here we get v1 v2 v3 v4. So these are the dual variables. So how can I define the u and vi? Now ui for the allotted cells, the allotted cells, this is for allotted or allocated cells, ui plus vj equal to cij. Okay, so this is for allotted cells only. So that meaning is how many allotted cells we require means to proceed the MODI method, the allotted cells must be that is, this is the one of the key criteria we want to check it. So number of allocated cells equal to number of source plus number of destination minus 1. So what is the number of source means? Number of rows, that is we call as a m rows. Here number of destination is n columns minus 1. So number of rows is 3, number of column is 4. So that is equal to 6 in our problem. Okay. So from the initial basic feasible solution allotted cells are 6. So that is no need to, this is the non-degenerate problem. Okay. So we can proceed further, there is no without. If it is not there, we have to give allocation 0 to or epsilon to some other cells to make it. Suppose it is not equal to number of source plus number of destination minus 1. This is not satisfied means we want to use the some dummy allocation to the any one of the, that means least cost we want to give it. Okay. So this is not a degenerate problem, it is a non-degenerate problem only. So we can proceed further. Okay. So now allotted cells, this is the allotted cells equal to ui plus vj equal to cij. So what is the clear idea? What is ui? So what are the allotted cells? Allocated cells are allocated cells are from the northwest corner method C11, C12. So allocated cells are C11, C21, C22, C23, C31 and C32, C33 only, C33 and C34. So totally these four cells are allocated, correct? This is C11, this is C11, this is C21, this is C22, C23, C33, C34. So that meaning is that way only we allotted. So now I want to determine the allocated cells are Ui plus Vj. So C1 means, so V1 U1 plus V1 equal to C11. C21 means U2 plus V1. C22 means U2 plus V2. C23 means U2 plus V3. Then U3 plus V3 is C33 and U3 plus V4 equal to C34. Here how many unknowns? 7 unknowns will be there. Okay, U are 3 unknowns, V are 4 unknowns. But I have the equation is only 6 equations will be there. So 6 equations, seven unknowns. So clearly one variable is a basic, one variable is a free variable. I can assume that any one of things is a free variable. I usually what will do is, what are the most allocated will be there. That is second row only the most allocated. So I assume that U2 is 0. U2 is 0 means what will happen? U2 is 0 means V1 is C21. So the cost is C21 means V1 is 9 we will get. Correct? So only allocated cells only we can. U1 is, then U0 means V2 is 12. V3 is 13. Next is another allocated cell is, suppose U1 plus V1 is C11. So U1 is minus 1. Then U1 is minus 1 we got it. And then V3 is 13. U3 plus V3 is C33. So U3 is 3. So U3 is 3. U3 plus V4 is C34. So V4 is 2. So we clearly determine what is the U1, U2, U3 and V1, V2, V3. This is the step. So first of all I will calculate U1, U2, U3, V1, V2, V3, V4 by, this is the formula. From the allocated cells only we want to say that. So what is the formula is, for the allocated cells, Ui plus Vj is Cij. Using this fact, we have to find U1, Uis and Vjs. This way only we find. Next step is for the non-allocated cells. For non-allocated cells, so now we are going for the non-allocated cells. we find the penalty or difference Dij. Dij formula is nothing Ui plus Vj minus Cij. This is the formula. I want to find the Dij value. How can I will get it? That is very simple. So, if till now we are finding the allocated cells, now non-allocated cells. These are the non-allocated cells. So, we first of all we make it to avoid the confusion. Non-allocated cells is we take the double lines. These are non-allocated cells. Yes. So, these are the non-allocated cells. I want to do it. U1 plus V2, 11. 11 minus 6, we will get it as 5. The difference is 5. Difference is 5. U1 plus V3, 12. 12 minus 10 is 2. Minus 1 plus 2 is 1. 1 minus 9 is, you will get it as minus 8. 0 plus 2, we will get it here is minus 5. Here is 12 minus 2. 3, 15. 15 minus 5 is 6. Okay. This is the Dij value, we find it, correct? So, Dij values we found that. Next is I want to check among that which is the maximum positive number. I want to check it. What is the maximum positive number from the Dij? Here 5, 2. So, minus 8 I don't want to consider. So, 5 is the maximum. Here is no. So, 6 is the maximum number. So, I will fix it. 6 is the maximum. Now, I want to make it, okay, 6 is the maximum number. Now, I want to form a loop. So, the loop formula is, you take as here is assign the theta. Now, theta plus you assume it. So, I started from here, also I ending to here from the allocated cells. So, I can travel row wise or column wise, anything you want to interested, you will go. So, first I will go travel by the allotted cells. So, I will go by the column wise. From here to here I will go. Okay. Here you will write it as theta minus. Next step, I will go by this row right and left, but I choose the right. The reason is, if I go to here, then I will go here. Yes, C11, but after that there is no allotted cells. So, I cannot come back to the same position. So, that is why I will go this direction. So, this is theta plus theta minus, here theta plus. Next step, I want to come here only. This is the only way chance will be there. So, I will come here. This is theta minus. Now, I will come here. So, I started from here. I will end to here. This is called loop. So, what is my next step is, wherever the theta minus, I want to, what is the allocation I want to, what is the theta minus? Theta minus, I want to find the theta value as minimum of, what is the theta minus allocation? Okay. Here theta minus is 10 allocated there. Here theta minus is 20 allocation is there. So, minimum of 10, 20. So, that is 10, correct. So, now what I want to do is, wherever the theta minus, I want to reduce that the theta value. Wherever the theta plus, I want to add it. That's the allocation. So, from that we can write in the form here. So, only 10 is I want to allocate it. Here is a theta plus. So, theta plus means here I want to allocate it 10. Here I want to allocate it 10 minus 10 is 0. So, there is no allocation, that is the meaning. Here is 20 allocation previously will be there. Now, plus 10 is 30 allocation. Here previously 20 allocation, now I will make it as 10 allocation. Correct? These three things only we have done. Previously from that this is not unchanged. These are 35, 110, here 30. Here also you want to check it. These are degenerate or not. That is m plus n minus 1. That is 6 allocations are there. Then only we can again proceed the Modi method. Okay. So again I want to introduce the dual variable u1, u2, u3, v1, v2, v3, v4. Now you look this problem again the previous case. So 6 equations are there, but 7 unknowns will be there. So again I will assume that any one of the variable is a 0. So I assume that u2 is 0 because 3 allocation already there. So u1, u2 plus v1 is 9. So v1 must be 9. Here is 12. Here is 13. Then u1 plus v1 is 8. So then u1 is minus 1. v2 is 12. u3 is 3. u3 plus v2 is 9. So u3 is minus 3. u3 is minus 3 plus v4 is 5. So v4 is 8. This way we define. Next is non-allocated cells. I want to notice these are my non-allocated cells. I mark it. This is for only for I want to clearly where is the non-allocation is happen. Okay. So I want to add, I want to find the Dij value. Dij formula is Dij equal to ui plus vj minus cij. So now u1 plus v2 is 11. 11 minus 6 is, you will get it as 5. Similarly, you will get here is 2. Here you will get it as 2 because 7 minus 9 is 7, here minus 2 will come, correct? 7 minus 2, here is 12 minus 10 is 2. So here minus 2, here 1, here you will get it as minus 6, here you will get it as minus 8. Now among that most positive number is this guy only. Yes. So here is the theta value I want to assume it. This is theta plus value I want. So now I go by and come back from the allotted cells only. So allocation allotted cells, I will start from here. I can go here, but what is the problem? Then I will go to choose here. Hereafter I cannot come back. So I will not go here. So first I will go to up to here, from here to here. Next I can go this way or I can go this way. If I choose this way, I cannot come back because there is no allocation in the row or column. So that's why it stuck. So that is why I choose here this way. Then here is the only option to allocated cells. Then it will come here. So here you can write as a theta minus, here theta plus, here theta minus. So now I want to find the theta value. Theta value is what? Minimum of the cost of theta minus. Here is 10, 35. Okay. So you will get it as the value is 10. So now I will proceed to the problem. So here 35 minus 10, that is become 25. Here previously 10, now add the 10 is, you will get it as 20. Then here is 10 minus 10 is 0. Here is 10 minus 10 plus, there is no allocation previously. Now I allocated here is 10. Yes. So these are the previous result, previous iteration value. 10, 30 here, and here 30. Again you will check. So here also 6 allocated cells are there. So still the problem is non-degenerate only. Now introduce the dual variables, that is U1, U2, U3, V1, V2, V3, V4. So now I can choose any one of the things because all the rows are 2 allocation will be there. So I can assume U1 is 0. You can, any variables, you can assume that one variable is 0. It does not make any problem. Okay. The result will not change. So U1 is 0. So now V1 is 8 will come. Then U1 is 0. V2 is 6 will come. So 8 plus U2 is 9. So U2 must be 1. Then U2 is 1. V3 is 12. Then 6. So U3 must be 3. 3 plus 6 is 9. 9 over here is 2. 3 plus something is 5. So V4 is must be 2. So clearly from the allocated cells we will find that Ui and Vij. Now non-allocated cells I want to mark it out. These are the non-allocated cells. This is to avoid the confusion. Nothing. You no need to mark it also, directly you can proceed also. It does not make any problem. So these are the non-allocated cells. I want to find the value. Okay. So 12 minus 10 is 2. Here is minus 7. Here is 1 plus 2 is 3. 3 minus 7 is minus 4. Here is 3, 15. 15 minus 16 is minus 1. 11 minus 14 is, you will get it as minus 3. So only positive value is here only. So that is the largest value, we can assume it. So now I assume that this here only the theta plus. Now I will start from here and I have to come back here from the allocated cells. So I have the only possible from the column wise is only here only, correct? Because there is no allocated here. So then I will come here. Then I will go to here only chance. Now I will not go to here and here. So directly only go. Okay, it is possible directly only will go. So this is theta plus, this meaning here is theta minus here, theta plus here, theta minus. This is the way will be there. Now I want to find where is the theta minus is theta equal to minimum of, where is the theta minus is 30, 25. So among that is minimum is 25. So I have to add wherever the theta minus is 25. So here I want to say is 25 minus is 25 is 0. So here is 20 plus 25. So you can directly write it as 45. Here is 30 minus 25 is 5. Here is 25. Then here we already, there is no affected. So here you can write 10. Here you can write is 10. here is 30. Again you will check, number of allocation is 6. So still the problem is non-degenerate only. So we can start with the Dewey variables u1, u2, u3, v1, v2, v3, v4. The same way allocated cells u1 plus v2 is 6. So I want to say one of the variable is 0. So here also I will take u1 is 0. So v2 is 6. v3 is 10. Then so v2 is 6. u3 is 3 only. u3 is 3. So u3 is 3. So v4 is 2. Here is 10. So u2 is 3. So now I want to find v1 is 6. So this is the dual variable. We find the values. Now I will go for the non-allocated cells. What are the values will be there? Okay, these are the non-allocated cells. Suppose 0 plus 6 minus 8 is minus 2. 0 plus 2 minus 9 is minus 7. 3 plus 9, 9 minus 12 is minus 3. 3 plus 2 is 5 minus 7 is minus 2. 3 plus 6 is 9, 9 minus 14 is minus 5. 13 minus 16 is minus 3. So now all the Dij are negative, less than or equal to 0. Then we got the optimal solution. So this is our optimal solution. So then what is the allocation, the total cost we will calculate. 10 times 6 plus 25 times 10 plus 45 times 9 plus 5 times 13 plus 10 times 9 plus 30 times 5. You please evaluate, you will get the answer is 1020 only. So this is the optimal solution. Okay. So modify distribution method gives the optimal solution, but you will check it this way. Suppose you start from the Vogel's method. So what is the Vogel's method allocation? So Vogel method also we will get the same solution only, correct? Here is same solution will come from the Vogel's method also. 10, 25, 45, 5, 10, 30. So that is why sometime you start with the Vogel's method, initially we will stop it. Okay. Sometime very few iteration only will happen. So whenever you require to solve the optimal solution, please start with the Vogel's method. From the initial basic solution from Vogel's method is more, within 1 or 2 iteration you will get the optimal solution. I hope you understand how to find the optimal solution for the transportation problem. Thank you for watching this video.